On to problem number 2 of the semi-final, number 2 of the 2006 MIT integration B, which is the indefinite integral of 25 over the square of 3 cosine x plus 4 sine x. So this is actually a very cool problem. We have two methods we propose. If you like whatever method we propose, please like our video. If you have an alternative method, please, we'd love to know about it. Please share with us. So let's see the two methods that we propose. So the first method would entail dividing both the numerator and denominator by cosine squared x. So we want to introduce that tangent x element into this integrand. So when we multiply or we divide both sides by cosine squared, both the numerator and denominator by cosine squared x, and that we have achieved by just multiplying by 1 over cosine squared x or multiplying by secant squared x. So what that becomes is that we do have both 25 secant squared x over 3 plus 4 tan x all squared. And so we can go ahead and substitute and say let u be equal to tangent of x, and that what means is that du dx is secant squared x, and so we can now substitute for secant squared x dx, this part here, with du. And so now our problem in the x domain gets transformed to what we have here in the u domain, which is 25 over 3 plus 4u all squared. So this is a fairly tractable problem from here. So what that becomes is it becomes negative 25 over 4 1 over 3 plus 4u, plus obviously the integration constant. But since we had substituted for tangent x with u, that means that our final problem of the indefinite integral of 25 over the square of 3 cosine x plus 4 sine x is negative 25 over 4 times 1 over 3 plus 4 tangent x. Now we can express the tan x in the form of sine x over cosine x. So we have negative 25 4 over 1 plus 3 plus 4 times sine x cosine x, and then you multiply with sine x both the numerator and the denominator, and that becomes negative 25 over 4 times cosine x over 3 cosine x plus 4 sine x. Now that can be further now expressed as the final statement. The indefinite integral of 25 over the square of 3 cosine x plus 4 sine x is negative 25x over, we've multiplied 4 across, over 12 cosine x plus sine 16 sine x. And that, ladies and gentlemen, is the final answer that we were looking for. So that's method 1. Let's look at the second way of doing it. The second method, what we're going to do is we're going to express the denominator in a slightly different way, and that is we would like to find the square root of the square of 3 and 5, which is the square root of 25. So we apologize, we've just rewritten this part here, but what that means is now this is the same as 3 is the same as the square root of 25, which is 5 times 3 over 5, plus we see 4 here is the same as the square root of 25 times 4 over 5. So it's very important to show that if you have a triangle and you have angle phi, we could express if we put 4 there and we put 3 there, and the hypotenuse becomes 5, that angle phi is the arctangent of 4 over 3. It is the arc cosine of 3 over 5. It is the arc sine of 4 over 5. So that is phi, that is phi, that is phi. So the 3 over 5 there can be expressed as the cosine of the arc cosine of 3 over 5, which is the same as the cosine of the arc tangent of 4 over 3. So we've written that like that, and we've also decided to pull the square root of 25 out there. And then 4 over 5 is the same as the sine of the arc sine of 4 over 5, which is the same as the sine of the arc tangent of 4 over 3, which we've written here. So the square root of 5 obviously is 5, and then when you square it, it becomes 25. But then you have this part here becoming cosine of x minus the arctangent of 4 over 3. And when we square that, it becomes cosine squared cosine squared of x minus arctangent of 4 over 3. So the 25s there cancel. And so we're left with 1 over the arc, the cosine, 1 over cosine squared x minus arctangent of 4 over 3. So this here is obviously simply the integral of the secant squared of x minus the arctangent of 4 over 3. So as we said, we have the integral of 1 over cosine squared x minus arctangent of 4 over 3, which is the same as the integral of secant squared of x minus arctangent of 4 over 3. That integrated is tangent of x minus the arctangent of 4 over 3, and we want to express it in a form that obviously is the same as what we saw in the first method. You could stop here, and I think that would still be okay. But we know that the tangent, if you have tangent of a minus b, the same as tangent of a minus tangent of b over 1 plus tangent a tangent b. And that's what we've done here. So we have tangent of x minus tangent of arctangent of 4 over 3 over 1 plus tangent of x times tangent of the arctangent of 4 over 3. So this becomes 4 over 3. This also becomes 4 over 3. So in essence, we have tangent x minus 4 over 3 over 1 plus the 4 over 3 times tangent of x. Let's try to express tangent x in form of sine x over cosine x and see how that translates. So we have tangent x minus 4 over 3 over 1 plus 4 over 3 tangent x. Tangent x is expressed as sine cosine x, sine over cosine x, which minus 4 over 3 over 1 plus 4 over 3 times sine x over cosine x. And then now we can multiply by 3 cosine x both to both the numerator and denominator. So we do have 3 sine x minus 4 cosine x over 3 cosine x plus 4 sine x. But you could say, well, this is not the same as what we saw in the first method, because we got 25, I think it was negative 25 cosine x over 12 sine x times 16 cosine x or something like that. We can show that by just subtracting with a constant. Let's say if we subtract by, I think, negative, if we subtract 3 over 4 or 3/4, and we still have another arbitrary constant, because this would still be a constant, right? What that becomes is, it becomes 3 sine x minus 4 cosine x in the numerator, minus 3 over 4 times 3 cosine x plus 4 sine x, and over 3 cosine x plus 4 sine x. And so we see that we have negative 4 cosine x subtracted here, and we have 3 sine x, so this and that go away. And then when you add this together, you get negative 25, and then the 4 comes back into the denominator. And so the final answer is very similar to what we got in the previous method, which is negative 25 cosine x over 9 over, there's a mistake here, so 4 times this becomes 12 cosine x, and then we have 16, yes, sine x. And we can show that the two expressions that we got for the two problems are identical, especially if there is a constant term there. So let's see, we have two expressions we are showing here. We would like to show that they are identical, except that there is a difference of a constant. So we've plotted this first expression as the red, and then the second expression we've plotted here is green. So the initial plot you see is different, but if we express the first expression and then we add a specific constant a and we let it move, we see the purple coincides with both curves at certain constant values of a. So these two expressions as answers to an indefinite integral, they are simply the same. They're not different. And so sometimes you may be scared, and it's like, okay, these are two answers that are different, but the difference could just be that constant that you're looking for. Well, I hope you did enjoy this version of the solution. Until next time, bye-bye.